Hello everyone, welcome to my math class. In this video, we are going to look at logarithm laws. Let's get started. First, let's recall the order of operations. In math, we use bit math to apply operations. It means brackets have the highest order, and then we have index. After that, we have division and multiplication. They are at third level. And if we have them at the same time, then we will apply the operations from left to right. And addition and subtraction, they are the lowest level. Therefore, for the above example, we can follow bit math to evaluate to get the final answer. Then let's move to logarithm. In operation, logarithm acts as a ladder. So what does this one mean? It means logarithm can lower the order of the operation. For example, if we have m times n, and this one is multiplication, and then if we take log to get log mn to base a, and this one can be calculated using log m to base a plus log n to base a. And this one tells us the multiplication of mn is lowered to addition. Then similarly, we can look at m divided by n. So this one we have division. And then if we take log, then this one will be equal to log m to base a minus log n to base a. Therefore, the division between m and n has been lowered to subtraction. If we have m to the power p, and now m to the power p, the operation involved is index. And then for this operation, it will be lowered to multiplication. So it means if we are going to take a log for this expression, then it will be equivalent to p times logarithm of m to base a. Therefore, the index p has been moved to front to become the coefficient. Therefore, the operation has been lowered to multiplication, p times this log. These are the three important laws for logarithm, and we can use exponential form to prove these laws. In addition, we are going to remember the following two identities. It means log 1 to base a will always be 0, and log a to base a is always equal to 1. So it just refers to the exponent in the exponential form. And then for these laws, the base a should always be positive, and it cannot be number 1. Then for the argument m, n, they should be positive. Now let's look at the applications. First, we have the expression log 200 to base 10 plus log 5 to base 10. Then we want to evaluate this expression. First, we see the logarithm. We have two of them, and the base is same. And the operation involved is plus. Now, by comparing with the laws, we see it is connected to the first law, and for this one we will keep the logarithm, and then for these two arguments 200 and 5 will be multiplied together. So it's 200 times 5. It will be equal to log 1000 to base 10, and then 1000 can be converted to 10 to the power 3. After that, we are going to use the third law, because here we have the index. And based on the third law, this index can be put to front. Then we will have 3 times log 10 to base 10. And then for this, we can use the fifth law, because the base and the argument is the same. Therefore, it will be converted to number 1. And final answer is 3. To the second example, we have logarithm 32 to base 2 minus log 8 to base 2. Then for this, they have the same base, and the operation involved is minus. Then we can use the second law. It will be converted to log to base 2, and then for these two arguments will be converted to division. So 32 divided by 8, we have log 4 to base 2, and log 4 can be written as 2 to the power 2. And by using the third law, the index will be converted to front, then we will have 2 times log 2 to base 2. And for this log, the base and the argument is the same. It can be simplified to number 1. Therefore, we have 2 times 1, which is equal to 2. Now let's look at example 3. So here we have log 81 to base 3. So if we can recognize 81 is 3 to the power 4, then it can be converted to log 3 to the power 4 to the base 3. Then the argument, we have the exponential form. By using the third law, we will have 4 times log 3 to base 3, because this exponent can be put to front. After that, we will have 4 times 1, because log 3 to base 3, by using the fifth law, we will have number 1, and then final result is 4. For example 4, we have log 5 to base 10 plus 2 times log 7 to base 10. So for this one, we can't combine them immediately by using the first law, because there is a coefficient before this log, so it means 2 times this logarithm. And in this case, we have to deal with this coefficient by using the third law. We put the coefficient back to the index of the argument. It means we are going to convert the expression to log 5 to base 10 plus log 7 squared to base 10. Then we have the logarithm with the same base, and the operation between them is plus. By using the first law, we will have log to the base 10, and then for these two arguments, we are going to multiply them. Therefore, we have 5 times 7 squared. Then this one, we will have 49 times 5, which is 245. Therefore, the final answer is log 245 to base 10. Now it's your turn to practice how to apply these laws to simplify the following expressions. You can pause the video, and when you finish, you can check the answers. That's all for today's content. Thank you very much for watching. I'll see you next time. Bye.